our fourth video in the series on the lecture on effect of temperature on the states of matter. And in this particular lecture, we will learn about the third consequence or the third point about what happens when heat energy is added to any state of matter. When you add it to solid or a liquid or a gas, what happens? And what happens when you remove heat from it? So the third outcome is when heat is added, atoms move away from each other. If you add heat to a solid, the atoms that make up that solid would start to move away. Now, I hope you remember that atoms in a particular solid, in any particular solid, are tightly packed and they are in motion, which is called vibratory motion. They are moving left, right, but in a confined space. So they cannot move much, but they simply move left, right, or they can move up and down, or they can move slightly diagonally, but they can only move in a certain fixed space. So this atom can only move here and here or here and here. So they are simply vibrating, right? So now let us see what happens when we add heat energy. The third point is if we add heat energy to it, these atoms in the solids will move away from each other. And when they move away from each other, what should happen, right? What will happen is this is something that we will see. And let us go back to our own very enjoyable simulator. I mean, I enjoy it, but I don't know whether you do. So let us go back to solids. So this is the solid state of water that I've chosen. The temperature is minus 127. This is too low. Now you see the molecules of water. Now molecules are made up of atoms. Anyways, so these molecules of water are very close to each other and they are vibrating. Now if I add up heat, let us observe what happens. Where will these molecules go? Will they come closer to each other or move far away from each other? Now let us start heating. Let us add heat to it and let us bring the temperature close to, so this is minus 3 degrees, and let us go close to 0. Just a little bit of, let's bring it slightly down and slightly down and see. Okay, so this is 0 degrees, right? We still have ice here. So these molecules of water are still vibrating very close to each other. And now let us add more heat. Let's add more heat. Let's go close by. Let us see at 21 degrees. Okay, so there's a greater deal of motion. The particles are vibrating more. They've started to move around. Now remember, the particles are farther away from each other. Can you guess what state of matter this is? I mean, this is the solid state. And when you add heat, when molecules start to move away from each other, see, now they have more space to move around. If you add more heat, what is the state that you see now? Isn't this the liquid state of matter? You see the liquid state of matter. If I add heat to the liquid state of matter, the particles are going to move further away from each other. You see, can you see the space between these water molecules has increased? Let us add more heat and see, can we increase the space? More the heat energy, more is the space between particles. And now just for a moment think, what state of matter might this be? Isn't this the gaseous state? Because in the gaseous state, particles have a lot of space between them to move around and they can freely move. So by adding heat energy, what have we done? We have, by adding heat energy, changed the states of matter. You can change a solid into a liquid by adding heat. So we are adding heat and see the solid became a liquid. There is more space, and if you add more heat to a liquid can be converted into a gas, and this is what you see here. Let us add a little bit of more heat, and this is around 142 degrees. Have an observe. The more the heat energy, the states can be changed. If you add up heat energy, you can convert a solid into a liquid and a liquid into a gas. And this is exactly what happens when you take a cube of ice and put it onto a hot container or on a hot plate. It gets converted into water. And if you add more heat to water, what does it get converted into? It gets converted into steam or water vapors. Most importantly, water vapors. And if you take heat away from these molecules, you can still change the state. If you take heat away from gases, you will convert them back into liquids. So you see what we've done here by decreasing the temperature to 26 degrees? We have changed the gas into a liquid. And if you further cool it down, liquids can be turned into, you see, what have we done? We have turned liquid into a solid. Now they don't have much space to move around. So what have we learned in this particular video are two things. atoms, when you add heat to an atom, they will move away from each other. When you take heat away from atoms, they will come close to each other. The first point. The second point that we learned is the states can be changed by adding heat. So if you add heat, let's say this is heat, if you add heat to a solid, it will get converted into a liquid. And if you add heat to a liquid here, it will become gas. So ice becomes water if you add heat to it, and water becomes steam, or you can say water vapor if you add heat to water, right? But if you take heat out of steam, if you cool water vapors or steam, what you will get back? If you take heat out of steam or out of any gas, you can change the gas into a liquid. And if you take heat out of any liquid, you can turn the liquid into solid. So if you take heat out of water, you can make ice. Now, you can imagine as many things as you want as an implication of the information I've given you. Air is a gas. If you cool it, you can get liquid air. And if you can further cool liquid air, you can get solid air also. Well, sky's the limit for observation. Thank you. I'll see you in some other video on some other day.